we can go to target 3, where it's talking about compute the number of positive divisors of 2 to the 20 times 5 to the 25 that are multiples of 200, but not 50,000. So what we want to do here is, well, the first step here, since we're given our number as a prime factorization, we should probably prime factorize these two so it becomes easy to see what's a divisor and what's not, right? So prime factorize 200. After prime factorizing this, you get 2 to the 3 times 5 to 2 and 50,000. You would get 2 to the 4 and 5 to the 5. What you notice here is since 2 to the 4 includes 2 to the 3 and 5 to the 5 includes a 5 to the 5 squared term, 50,000 is a multiple, or 200 is a multiple of 50,000, or yeah, 50,000 is a multiple of 200, meaning that every number that is a factor or a multiple of 50,000 that is a divisor of this is also a divisor of 200. So what we can do is, and since there are less of these, what we can do is we can get all the total number of divisors which are multiples of 200 and subtract that from the number of divisors, or take that and then subtract away the number of divisors which are multiples of 50,000. And this is a smaller number, so then we'll get a number which represents the number of divisors which are multiples of 200 and not 50,000, since those include each other, right? We sort of imagine it as you have an outside group, which is every number, which is a divisor of 200. And inside of that, we have the 50,000 group inside of there. So if we just take the outside box minus the inside box, we end up with the number we're looking for. So to figure out the number of divisors, we just take every possible like integer value exponent here, all the way up to the number we're looking for. So for 200, we have 20 to 3. So we have 20 minus 3 plus 1 possible exponents there. And then for 5, we have 25 minus 2 plus 1 possible exponents. So that becomes 18 times 23, which equals 432. Now for the second factor, we have 2 to the 4 going up to 2 to the 20. So that's 20 minus 4 plus 1 possibilities for that exponent. Then we have 25 minus 5 plus 1 possibilities for this exponent, which gives us 17 times 21, which is 357. Then finally, we can just take 432 minus 357, and we end up with our answer 75. That was target 3.
Hey, this is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.